Greetings, fella. This is Medson, your boy. Um, Before we do anything, if you haven't joined the family by subscribing and turning on the light for all the videos that I upload in my channel, please do so. Join the family before we continue. Today we are going to deal with Euclidean geometry. This it's a part of geometry, since we know that geometry has three subsections. Number one being triangle geometry, which is called now trigonometry. The second one, it is coordinate geometry, which is also called the analytical geometry. Okay, and then the third one, it is Euclidean geometry, which deals with angles, lines, and cycles. Okay, now let's go for it today. Step number one, we are going to revise our information. So this is called revision. Okay, we are going to revise. Okay, since we are going to revise, we are going to check some few things that you know. Okay, number one, on this one we speak of what we call parallel lines. Okay, when you speak of parallel lines, most of the time we categorize it as fan. Okay, so this is fan. Whenever we speak of fan, we speak of the parallel lines. Okay, if this line is parallel to this one, if this line is parallel to this one, hence the angle beneath is equals to the angle beneath. Okay, so those are called corresponding angles. They are corresponding because of the parallel lines. Then we have the other ones, this one plus this one, they sum up to 180 degrees. Hence, whenever we add angles and they are equals to 180 degrees, we call them supplementary. Okay, then we have this angle which is that one. Okay, now before I continue with this one, let's go back here. Here we call these two angles that they are co-interior angles that are supplementary. These ones are corresponding angles, and these ones are co-interior angles, and these ones now are alternating angles. Okay, and make sure that whenever you do these, you remember that there is something called parallel lines. They cannot correspond unless they are parallel lines, so you need to list the parallel lines. Okay, now we continue and go to triangles. Now, whenever we deal with triangles, there are types of triangles we need to allude on. Okay, there is this triangle I would love us to talk about. This is A, this is B, and this is C. Okay, this says this line and this line are equal. This triangle is called an isosceles triangle. Okay, this is an isosceles triangle. An isosceles triangle is known that angle B is equals to angle C. I remember in a primary level we call them base angles of an isosceles, but as we grow up we say these are angles that are opposite equal sides. Okay, these are angles that are opposite equal side. But if we write that we have AB is equals to AC, then we are going to say these are sides that are equal, sorry, these are sides that opposite equal angles. Okay, so these are sides that are opposite equal angles. So that's how we deal with an isosceles triangle. Remember, an isosceles triangle is the most appearing. Okay, why do we say it's it's the most appearing? Because once we have the two radii, a radius and a radius, therefore automatically if there is a triangle being formed there, we know that there is a presence of an isosceles triangles. Okay, now that is very important for us to know this type of a triangle. Okay, then we continue with other triangles, but basically this is what we need to know: the sum of the interior angles of a triangle that are always supplementary, they are equally always equals to 180 degrees. Then number two, we have this exterior angle of a triangle, which this angle is equals to the sum of the opposite angles. That is an exterior angle of a triangle. Okay, then we go about and deal with a right angle triangle. Okay, now a right angle triangle has a theorem and a converse. A theorem is when we are given this to be 90 degrees and the Pythagoras does hold. Okay, so hence this is a theorem of Pythagoras. But a converse is when we are not given this angle P here. So since we're not given a P here, but when we try Pythagoras theorem, it works. Hence this is a converse of a Pythagoras theorem. Okay, what is the word converse meaning? The word converse is it's like a shadow of something that behaves like another thing. So whenever I say there is a boy who calls himself Medson, that boy is not Medson, but he behaves like Medson. So that boy is a converse of myself. Okay, so that is what basically a converse is. It's like a theorem, but it's not a theorem. Okay, then we go about and deal with a congruent. You remember the reasons for congruent. Okay, I think that is side, side, side. There is side, angle, side. There is angle, angle, angle. Then there is right, hypotenuse, side. There are four of reasons of a congruent triangles. Okay, this was just a revision, guys. Okay, now here again in types of triangles, we have this other one. Most of the time we tend to forget it. This type of a triangle, this is A, this is P, and this is Q. Okay, this type of a triangle is called an equilateral. Equilateral triangle. An equilateral triangle, remember that each angle, that means angle A is equals to angle Q is equals to angle P. They are all equals to 60 degrees. Why are they equals to 60 degrees? We call them the what? The sum angles of a triangle, which we have dealt with here. Okay, why are they equal now? These are angles of an equilateral. Angles of an equilateral. Okay, these are angles of an equilateral. Also the sides we have AQ, which is equals to AP, which is equals to QP. These are all equal. Why are they equal? Because we said these are what? Are sides of an what? Of an equilateral triangle. Okay, so this is the information we need for us to be able to get into our theorems. Okay, I hope you guys are following me. Okay, now let's continue from here. Now from here, we now introduce you to a circle. Oh, sorry. Okay, let's try again. Oh, okay, that's now a triangle. Okay, now this is a triangle that I'm going to introduce you to. Okay, now this triangle has lines, but before it has lines, it has the what? It has the center. This is our center. So this is a what? This is a circle. That's sorry, it's not a triangle, it's a circle. It's a circle that has a center. Now this line that is bold, that is showing us that is a what? It's a circle, is called the circumference. Circumference. Okay, now let's go for it. I said this thing is called the circumference. 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 Okay, now I don't want to dwell much on that one. Then number two, what do we know? We have lines that are being drawn according to this. Okay, we know that whenever we have a line from the center going to the circumference, it has a name, and its name is called what? It is called a radius. Okay, that is a radius. Okay, then number two, we have again another line. The line is drawn from one circumference passing through the center to another circumference, and now this line is also called something. This line is now called a diameter. A diameter. Okay, now we have a radius. A radius is a line from the center to the circumference. Remember, if it does not reach the circumference, it's not a radius. Okay, then we have a diameter. Then again, we continue and have another line. This line is now from the circumference going straight to another circumference. Okay, let me fix this one. Okay. Okay. Yes. Okay. So this line is from the circumference to the circumference. Okay. It does not pass through the center. This line is now called a what? A chord. I remember visiting one of the schools and they call it a chord. And then I said, okay, it's a chord. It's a chord. So yes, it's a chord, and it's also called a chord by others. So don't blame me on that one. Okay, then we continue and have another line. This line now, it is outside the circle. Okay, it is outside the circle but touches the circle at one point. Outside but touches the circle at one point. This line is now called a what? Is called a tangent. So this is a tangent. Okay, so these are type of lines you need to know before we deal with anything. Okay, now let us continue a bit again. We have another line that is very mysterious, and you need to know it. Okay, it's from outside getting inside and going outside. This is the line. Okay, now this line is also have a name, and its name is now a what? It's now a secant. Okay, this is a secant. Okay, now I want us to be able to identify each line. Okay, now these are the types of lines that we have, but before we continue further, I would like us to dwell on the what? On the chord. The chord separates a circle into two, and these two parts are called segments. These, I'll try to make a column so that you see it. This line here, I want to color it, so we will say this line here, I'm trying to shade it so that you see it, guys. Okay, this part that I'm shading now is called a minor segment. It's called a minor segment. Okay, now since it's a minor segment, that means this one up here, it's now a major segment. Okay, so that means there are two types of segments that are being separated by a chord. So a chord separates for us a minor segment and a major segment. So that is very important for us to understand, because we are going to deal with segments, and we need to know what is a segment. Okay, I've tried to separate the two. The one here down there, it is called a minor segment. Let me write it. It is a minor segment. Remember, the separator of these two segments, it is the chord. This is a major segment. That is very important for us to know. Okay, now this is what we are going to deal with. Okay, now again, before I continue, I hope we grasped everything here. So here they were dealing with parallel lines, triangles, and one thing they highlighted here is that whenever we have a right angle triangle, we use Pythagoras theorem. Okay, then we went to isosceles, we went to equilateral, then these lines that are embarking or are embodied in the what? In the circle. Okay, that is what we have. Okay, now let's pass and work. Okay, so step number one, we have a theorem. This is now a theorem. It's a theorem under the center. This is a theorem under a center. Okay, why do we say this is a theorem? A theorem is something that has been proven to be true. So we do not argue with it because it's already been proven and it's passed to be true. Okay, now I want us to look at this statement. It says theorem number one. This is theorem number one. I'll write here. It's theorem number one. Okay, theorem number one says a line drawn from the center of the circle perpendicular to the chord bisect a chord. Wait, it's perpendicular. Once we say it's perpendicular, that means there is 90 degrees. Okay, so that's why this is our given. This is very important. Our given is that OP is perpendicular to AB. So since OP is perpendicular to AB, therefore the conclusion is going to say what? AP is equals to PB. Okay, so that means these two lines are now equal as they have shown here. Okay, and the reason it's what we were given. In the given, we are given a perpendicular, so that means it's line from the center perpendicular to the chord. This is very important, guys. I would like us to know that in this Euclidean geometry, we deal with the reasons very precisely. If you miss this, you will miss it all. Okay, so this is a line from the center perpendicular to the chord. Okay, then now here, secondly, I have what I call a converse. Why do I call this a converse of theorem 1. Why do you call it a converse of theorem 1? Remember, I said a converse is something that once behaves like a theorem, but it's not a what? A theorem. So this one, it is given that we have AP equals to PB. So now these two lines are now equal. Hence, what will be our conclusion? Our conclusion is that this angle here will be 90 degrees. And once that line becomes 90 degrees, it's now theorem number 1. Theorem number 1 says what? Line from the center perpendicular to the chord. Okay, then the converse says what? Line from the center to the midpoint of the chord. So why do we say this is a midpoint? It's because this line is equals to this other line. Okay, so since these two lines are equal, we now know that this is a midpoint. That is where it is being separated, that this line PB is equals to AP. Okay, that's why we said a line from the center to the midpoint of the what? Of the chord. Okay, now in full they said what? They said line drawn from the center of a circle to the midpoint of the chord is perpendicular to the chord. Now if this is so, therefore it is perpendicular. Same goes at the theorem. We said if it's a line drawn from the center of the circle perpendicular to the chord, therefore if it's perpendicular to the chord, that means it will bisect the chord. Those are just important aspects that we need to know whenever we are dealing with this. Okay, then another thing I need to emphasize here is that whenever we have a circle, okay, that's not a circle, I don't know, I don't want jail, so I'll try to draw a circle. Okay, I'll try to make it a circle. Yes, I think this is more like it. It's more like a circle. Okay, so now what we need to know here is that this being the center, this is a radius, and this is a radius. 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 So hence all these, we don't call them radiuses. We call them radii. The radii are equal in 1 second. So that means if this is O and this is A, this is B, this is C, this is D, this is E, okay, and this is F. Okay, now what do I know here? I know that OF is equals to OA, which is equals to OE, which is equals to OD, which is equals to OC, which is equals to OB. Why is it so? It's because these are words are radii. So these are equal radii. So that one will help you as we are going to check the problems. Okay, is that every time whenever you are dealing with these problems, they will require you to know the Pythagoras theorem. But knowing the Pythagoras theorem also, you need to know the what? That the radii are equal. Okay, now let's go for it. Aha, so we have arrived. Now say we are having this kind of a problem. Let's try and deal with this kind of a problem. It says O is the what? Is the center. Okay, here is O, it's being the center. Then we have OE, and they have written for us OE to be root 3. And then OF, we have OF, which is the radius. And they told us something. They told us OE is perpendicular to DF. OE is perpendicular to DF. Then calculate the length of DE. Where is DE? Here is DE, right? That means step number one, what do we need to do here? Remember, this one is now a right angle triangle. I have two sides. This one and this one. I'm looking for this one first. So that means I start on Pythagoras theorem. Let me write it correctly. I will say OF squared is equals to OE squared plus EF squared. Why is it so? It's because this is a Pythagoras theorem. Okay, since it's a Pythagoras theorem, let us now substitute. What is OF? OF is 2 all squared is equals to this one. It is square root of 3 all squared plus EF squared. Then I take this one to the other side. I will have EF squared equals to, we have 4 minus 3. Okay, then we know that this one will be equals to 1. This is EF squared, right? Then I put a root. Then EF will be equals to the root of 1 is 1. So it's 1 unit. Okay, since it's 1 unit, are we looking for EF? No. But we know, therefore, that EF is equals to DE. Why? We're told about what? We're told about the perpendicular, that OE is perpendicular to DF. Hence, the reason will say what here? It will say line from center perpendicular to the what? To the chord. That is it. We are done. Hence, we know that therefore it means that DE they are looking for is equals to 1 unit. So we are done. So this is how we are expecting you to answer such a problem. Okay, now let's continue to the second problem. Here is our second problem. They say AB is a chord. Okay, AB is a chord circle of a circle centered O. OE bisect AB. This is very important. Guys, you highlight such things. This is very important, okay? And then they've given us everything. Determine the radius of what? Of OB in terms of X. Where is OB? Here is OB. But let's check something here, okay? And they said AD. Where is AD? AD is 12 units. AD is 12 units. Here is AD here. Then we have ED. Here is ED here. Sorry. ED is here. Sorry about that. Then it is 8 units. And OD. OD from here to here, it is X. Okay, that means we can agree firstly that OB is equals to OE, which is equals to OA, which is equals to the sum of this and this, that is X plus 8. So we can say it is 8 plus X. Why are they equal? We said we will know that there's our what? Radius. Okay, since they are radius, now they said determine the length of OB. We have already determined the length of OB in terms of X. Okay, that is what they wanted on number one. Okay, that was number one. Then we go for number two. Number two, they said, hence calculate the length of OB, that is the radius. Okay, so now on number two, we go and say what? We are going to say step number one, before we calculate the radius, we know that since AD is equals to BD, this is what? This is telling us that this is a what? A line from center bisects. Sorry, line from center to the what? To the midpoint of a what? Of a chord. Sorry about that mistake. Okay, so this is a line from the center to the midpoint of the chord. Okay, which means what? Which means that angle what? Angle O D A is equals to 90 degrees. Why? It's because of that thing. Okay, then now we can do Pythagoras theorem. We couldn't do Pythagoras theorem without 90 degrees. Remember that. Okay, now we can say what? We can say OB squared is equals to OB squared is equals to OD squared plus what? DB squared. This is now a what? A Pythagoras theorem. Okay, now let's go for it. What is OB? OB, it is 8 plus x all squared equals to OD. OD, it is x all squared plus BD. BD, remember, it is equals to 12 units. So hence this one will be also 12, all what? All squared. Then from here we continue. That means these two here indicate that there are two sets of brackets. We open them. 8 plus x, and then we have 8 plus x equals to x squared plus 144. Okay, then let's multiply. 8 times 8, we do our FOIL. Our FOIL will give us, this one will be 64 plus, we will have what? We will have 8 plus 8, which is 16x plus x squared equals to x squared plus 144. Okay, then we take the right hand side to the left hand side. Hence, this will be 64 plus 16x, sorry, plus x squared minus x squared minus 144. Okay, equals to 0. We can see that this and this cancels out. I'm left with 16x. Okay, then let's just take the other thing back to that side. I'm sorry, 144. Then we'll minus what? 64. Okay, so here I have 16x. Now I check what is 144 subtract 64. Okay, now you check and make sure, guys, that if you don't know how to use without calculator, you go to your calculator straight. Okay, so 144 minus 64 will give us 80. Then we divide by 16 and divide by 16. Okay, then you know that 80 divided by 16 will give us what? 5. So x is equals to 5 units or centimeters. Okay, but we're not looking for this one. We are looking for OB. Therefore, OB is going to be 8 plus 5, which is equals to, okay? So when you say 8 plus 5, you'll get what? 13 centimeters. So that is how you go about answering such a problem. I hope you are following grade 11s and grade 12. Okay, now let's continue. Now we are on theorem number 2. Under a what? A center. So we have theorem number 2. Theorem number 2. Okay, now since we are dealing with theorem number 2, I want us to check something. An angle at the center of a circle is equal to twice an angle at the circumference subtended by the same arc. Okay, now we would not dwell much on arc, but we can see that we have, if we have here, I would like to indicate here, if we have 2x here, that means here we'll have x. If we have 2x here, that means here we'll have x. If we have 2x here, that means here we'll have what? X. That is what basically this theorem is trying to say. Okay, now what is important here? That they say O1 is equal to 2 times C1. Okay, the reason says angle at the center is equals to 2 times angle at the circumference. Okay, that is very important for us. Okay, so we need to note that one very well. And again, before I go to that problems, it is important that we know that all these three, they mean one and the same thing. It either it goes up, angle at the center is twice angle at the circumference, angle at the center is twice angle at the circumference. So in either way, sometimes they even give us a shape like this. They said we have something like this, then this is the center. They said like this, and then they go like this, and then they go like this. Okay, yes, they go like this, guys, and say this is O, and this is 1, this is 2, and this is C, and this is C1. Okay, now guys, there's nothing different about this. We are going to again to say what? We are going to say O1 is equals to 2 times angle C1. And the reason we'll say what? Angle at the center is equals to 2 times angle at the circumference. So guys, they always try to make sure that they confuse you, but if you see, you take your hands and put them here. Okay, then you go to the center, then from the center you go back here, guys. Okay, after going back here, now you go to the circumference. So there is our circumference there. Okay, so angle at the center is twice angle at the circumference. That is very important. Okay, now let's try and look at these 3 obvious questions. Okay, I know you will get their depth. Okay, so hence here we start with the first one, which is this one. O is the center of each of the circles. We are given X here. We are looking for X. How can I find X? I will say angle, normalize. If you are not given 1 and 2s, normalize using alphabets. So this will be AOB. So it's angle AOB is equals to 2 times angle C. Okay, why? It's because angle at the center is equals to 2 times angle at the circumference. That is very important. Okay, that means we check this one. What do we have here? We have 130 degrees is equals to 2x. Then we divide by 2, you divide by 2. Then x is equals to 130 divided by 2. I think that one should give us 65, right? Please guys, do confirm the answers. Okay, so that one will give us 65 degrees. So that is how we have found what? We have found our X. Okay, let's check the other one. Let's check Y. So again, you are going to do the same thing. You are going to say angle what? Angle AOB is equals to 2 times angle C. Why? It's because of the angle at the center. That is equals to 2 times angle at the what? At the circumference. Okay, what is AOB? AOB is 50 degrees, which is equals to 2 times Y. We divide by 2, we divide by 2. Therefore, Y is equals to 25 degrees. That is how we have found that Y. Okay, we can also go about in finding Z. Okay, let's go for it. I'll try to write here. I will have angle AOB is equals to 2 times angle C. What's the reason, guys? It is angle at the center is equals to 2 times angle at the circumference. Okay, what is AO? So that is 270 degrees is equals to 2Z. Then you divide by 2, divide by 2. We know that 270 divided by 2 will give us what? Will give us 135. So we know that Z is equals to 135 degrees. So that is how we deal with such problems on the second theorem. Okay, let's go to the next one. Now, I know you are moving with me because I don't want you to be left behind, right? So now we are here now on the third theorem under a what? A center. So under a center, we have theorem number 3. Okay, theorem number 3. It's very crucial for us to know this one. It says a chord subtended by subtending a right angle at the circumference is a diameter. Okay, but that is something we need to know. We're given that this is 90 degrees, hence that means AB is a what? A diameter. Sometimes we are from this side going that side. Let's say we are going that side. We are given that AB is a diameter. That means angle P should be 90 degrees. What will be the reason? The reason will be what? Angle. So when we go from this side going that side, we are going to say angle in a semicircle. That is very important. Angle in the semicircle. So this basically we can call it a converse, because in this case we are given, which is something rare, we are given 90 degrees. Okay, if we are not given the 90 degrees, you use the reason angle in a semicircle. But if we are not given, if we are given 90 degrees, we are going to say what? We are going to say chord subtends 90 degrees. Okay, now let's check the problems. Remember, now this is a right angle triangle right there. Okay, so now let's check these problems. These are the problems we are going to deal with. Okay, can I take the first one up here? Number one. Okay, we are looking at them. Are we given 90 degrees? No, we are not given 90 degrees. Step number one, before I look for x, I'm going to say angle Q is equals to 90 degrees. Why is it 90 degrees? Because this is an angles in a semicircle. Okay, angle in a semicircle. If it's angle in a semicircle, that means I can now use the sum angles of a triangle. So x is equals to 180 degrees minus 90 degrees minus 55 degrees. Okay, then we calculate the value of x. But before we do that, we need to know what will be our reason. Okay, so what do you say is our reason there? Our reason here, I've just said it, guys. It's a what? It's a sum of angles in a triangle. Hence the answer here will be what? 35 degrees. Okay, so that's how you answer such problems. Okay, now let's go and check number B. On number 2, here I will again say what? Angle what? Angle A B C is equals to 90 degrees. Okay, y is equals to 90 degrees. These are angles in a semicircle. Okay, so since it's an angle in a semicircle, that means I have 90 degrees now. Okay, so since I have 90 degrees, I will indicate that here there is 90 degrees, but this 90 degrees involve these two. So that means x will be equals to 90 degrees minus 52 degrees, which x will be, if you punch your calculator, you get 38 degrees. So that is how we do it, guys. Okay, now I like the third one. The third one, it's one I've been talking about. Okay, now let's look at the third one. The third one, step number one, I have these radii. These are two radii. Can you see them? That means I can use some angles of a triangle first. But before I do that, I will say angle A is equals to angle ABO. Why is it so? Which is the all equals to x? It's because these are angles these are angles opposite equal sides. Why do we say so? Okay, above one can list that we are having say OA, which is equals to OB, which is equals to OC. These are radii. Okay, so we can start with this one and go to this one. Okay, hence we can now say x is equals to 180 degrees minus 104. Remember, 180 minus 04, Then we divide that answer by 2 because we are dealing with now an isosceles. So x is equals to, we have 76, and 76 we divide it by 2, we will have 38 degrees being our what? Our answer. So that is how we do it. Step number 1, you list the radius. You list the radius here. After the radius, you list the equal angles. After the equal angles, you go to this one. Oh, wait, I didn't write the reason, which is very wrong. The reason here should be what? The sum of the angles in a triangle. Sum of the angles in a triangle. Guys, it is very important for us to deal with this. Okay, so I've found x, but is that all? No, we still have y here. Let me show you. Maybe some are saying, say we could have seen it, but you draw them. So we still have y. So how can I find y? How can I find y? I'm going to say angle ABC is equals to 90 degrees. Y is equals to 90 degrees. It's because these are angles in a semicircle. Okay, so since it's angles in a semicircle, that means I'm going to say what? I'm going to say 90 degrees subtract 38. Okay, so y is equals to 90 degrees minus 38 degrees. Hence, therefore, y is equals to 52 degrees. That is how you do it. Okay, I know there are a lot of things you need to know at the same time, but this is the fundamental of Euclidean geometry. These are theorems under a center, guys. Let's continue. We are not yet done. We still have a long way to go. Okay, now we have this one. This is now under a cyclic quadrilateral. What is a quadrilateral? We have dealt with quadrilateral in grade 10. Not only in grade 10, even back then we're dealing with quadrilaterals. So now these are cyclic. Why do we say they are cyclic? It's because each vertex touches the circumference. Each vertex touches the circumference. You can see that each and every vertex it's at the circumference. Hence, that's why we call them cyclic. So this is the first theorem under a cyclic quad. Theorem number 1, which is theorem number 4, by the way, under all the theorems. Okay, this one says what? It says this angle. It says this angle plus this angle, this equals to 180 degrees. It says angle D plus angle F. Angle F is equals to 180 degrees. That is angle F, right? Yes. Okay, so same goes. It's also continue and say or angle G plus angle E is equals to 180 degrees. Why? These are opposite angles of a what? Of a cyclic quad. So you don't write the whole weight, but it's in opposite angles of a cyclic quad. Okay, angle D plus angle F is equals to 180 degrees, or angle G plus angle what? Plus angle E is equals to 180 degrees. These are opposite angles of a cyclic quad which are supplementary. Okay, now let's go and deal with the problems. I love it because we introduce a theorem and we go for a theorem, for a problem. Okay, let me take the first one up here. Okay, this one, since I have this and that one, that means I'll say x plus 70 degrees is equals to 180 degrees. Why do we say so? These are opposite angles of a what? Of a cyclic quad. That is very important. Okay, therefore x is equals to 180 degrees minus 70 degrees. Hence x is equals to 110 degrees. That is how we found x. We can continue and find y, because we are going to say 80 degrees plus y is equals to 180 degrees. Why do you say so? These are opposite angles of a what? Of a cyclic quad. Okay, hence we know that y is equals to now 100 degrees. So that is how we do it, guys. Okay, now we can try to trick you like number 2 and number 3, but let's look at them because we are trying to lay this foundation. Okay, now let's check it. So here on number 2, we'll start by using the sum of angles in triangle ABC. Can you see triangle ABC? We are short of that x. So we'll start by saying x is equals to 180 degrees minus 68 degrees minus 80 degrees. Why do we say so? Guys, remember, we can't do anything without what? Without a reason. Okay, so why do we say so? It's because this is a sum of the angles in a what? In a triangle. Okay, then when we subtract like that, x is going to be 32 degrees. We have now x. Okay, having x helps us. Let's check for y. Y, I will say what? I will say 80 degrees plus y is equals to 180 degrees. Why? These are opposite angles of a what? Of a cyclic quad. Okay, that is supplementary. So that means y is equals to 100 degrees. Okay, then having y give us a leverage to find z. So we are going to say z is equals to 180 degrees minus 100 degrees minus 54 degrees. Okay, so why do we say so? Okay, remember we said we do nothing without a what? A reason. So we say so because this is a what? A sum of the angles in a what? In a triangle. So angle Z here will be equals to what? Will be equals to 26 degrees. That is how we do it, guys. Okay, now let me leave this one because this one is a bit similar to that one. You start by finding y, then this one and that one is equals to 180 degrees, opposite angles of a cyclic quad. Then you'll find your z. Okay, so now let me continue to the other one. Okay, I hope you guys are grasping the concept. Now let's go. Now this is the second theorem under what? A cyclic quad. This is a theorem. theorem number 2. Theorem number 2 is initially theorem number 5. Guys, I know you know that one now, okay? Now, this one says what? An exterior angle of a cyclic quad is equals to the opposite interior angle. That means what? That means D1 is equals to angle B. Here is D1, which is equals to angle B there. Okay, and the reason says what? This is an exterior angle of a cyclic quad. An exterior angle of a cyclic quad. Okay, that's our reason. Okay, now let's not waste any more time and get into it. This one says an exterior angle of a cyclic quad is equals to the opposite interior angle. Now let's get to number 1. We are going to say x is equals to what? 85 degrees. Why is x, this is x, equals to that one? Why do we say so? It's because this is a what? An exterior angle of what? Of a cyclic quad. This is very important for us, okay? That's an exterior angle of a cyclic quad. Okay, but I love number B. Can I end with number B? Can I jump to now number C first? This one first, then I go to that one, okay? So that means on this one, I'm going to say what? I'm on number 3 now, okay? On number 3, I'm going to say angle A is equals to 112 degrees. Why? This is an exterior angle of a what? Of a cyclic quad. Okay, now having that one, I can also find B. I will say angle B plus 92 degrees is equals to 180 degrees. Why do we say so? Those are opposite angles of a what? Of angles of a cyclic quad. But say how this and that one are opposite angles of a cyclic quad, which hence this means that B is equals to, you are going to punch on a calculator and say 180 degrees minus 92 degrees. Okay, you'll have B being 88 degrees. That is what we are having for number C. Now let me jump and do number B, which was number 2. This is very interesting, guys. It's very interesting. Let's deal with it. Okay, step number 1 on number B, we can see that we have a diameter here. BE is a diameter. So since BE is a diameter, step number 1, we are going to say angle C is equals to 90 degrees. Why is it 90 degrees? It's because of the angles in a semicircle. Angles in a semicircle. That means therefore y is equals to 90 degrees. Okay, we have y being 90 degrees. That's the first thing we know here. Okay, I hope you guys are following this one. It's very crucial. So let's indicate we have 90 degrees here. Okay, then we can see that this is an exterior, which is equals to the interior opposite, which is this one. So that means we know also that x is equals to 125 degrees. Why is it so? It's because of what? Of an exterior angle of a what? Of a cyclic quad. Okay, if it's so, I have 2 now. I'm lonely, short with 1. How can I find 1? This one is now 125 degrees is equals to z plus y. This is an exterior angle of a triangle. I hope you remember this one. It is standing like this, guys. It is standing like this. This angle is equals to this one plus that one. This is an exterior, guys. I hope you remember it from where we started from. Okay, so now we know that z is equals to 125 degrees minus 90 degrees. Okay, what did I do? I just transposed, guys, the 90 to the other side. Okay, hence we know that angle z is equals to 35 degrees. That is what we know. Okay, so I love the way they mixed everything on this second problem, guys. Okay, now let's continue to the third one. We are now on the third theorem under a cyclic quad. Okay, since you are under the theorem number 3. Theorem number 3 here, it's initially theorem number 6. What does it say? Angle at the circumference is subtended by the chord in the circle. On the same chord they are equal. The angles are equal, but in short we say what? Angles in the same segment are equal. This is very important. Angles in the same segment are equal. I did speak about the angle in the same segment, guys. I spoke about the segments. I said there is a minor segment and a major segment. So this one says angles in the same segment, they are what? They are equal. Okay, which means that angle A is equals to angle D. Angle angle B is equals to angle C. Angles in the same segment. That's our reason. Remember this one, don't confuse it. The vertices also must be in the circumference because it's under what? A cyclic quad. Okay, now let's go for it. This one will say what? This one will now say, let me take, can I start with number B? Okay, I don't want to start with number A first. Let me start with number B. On number 2, we are going to say angle X is equals to 32 degrees. Can you see X is 32 degrees? Why is it 32 degrees? We're going to say angles in the same segment. Angles in the same segment. Okay, now then from there I have now 32 here degrees. That means I can find B1. Okay, so angle B1, which was not required, will be 180 degrees minus 92 degrees minus 32 degrees. So angle B1, or the reason for this will be what? The sum of the angles in a triangle. Guys, can you see this triangle? I hope you see it, guys. Okay, so you're going to say 180 degrees minus 92 degrees minus 32 degrees, and you'll have your B1 will be 52 degrees. Okay, so that's what we have because of the sum angles of a triangle, right? Then For y, I will say angle B1. So y is equals to angle B1, which is equals to 52 degrees. Why? These are angles in the same segment. Sorry, in the same segment. Okay, so I am done with this one. I found everything. Okay, now let's take another one. I would like us to take number C first, which is number 3. Okay, I hope you fellas are following and looking carefully. This one, it is angle at the center. Can you see angle at the center is twice angle at the circumference? That means angle AOB is equals to 2 times angle D. Why do we say so? It's angle at the center is equals to 2 times angle at the circumference. Okay, so hence we have this one being 88 degrees equals to 2 times x divide by 2 divide by 2, x is equals to 44 degrees. Okay, so now I have 44 degrees. Okay, having 44 degrees, now I can see that this one is my diameter now. Since now this one is my diameter, I can find y. So first of all, I will say angle D is equals to 90 degrees. I don't know if you see this one. Angle D is equals to 90 degrees. Why? There's a diameter there, which means these are what? Angles in the in the semicircle. Angles in the semicircle. Hence, we know that y will be equals to 90 degrees minus 44 degrees. Okay, so that is our y. 90 degrees minus 44 degrees, which y will give us 46 degrees. That is what we are having. Okay, and if you look at this one here, this is an exterior which is equals to both of those, so we can find x very quickly. We are on number 1 now. Okay, so we can say x is equals to 70 degrees minus 40 degrees. Why? This is what? An exterior angle of a what? Of a cyclic quad. And I hope you guys are following this one, because this is very important. X is now equals to 30 degrees. That is how we have found x. And you can also find the other one, which is y. Okay, first of all, before I find y, I know that angle QPR is equals to angle QSR. Why? They are all equals to 30 degrees. Angles in the same segment. Okay, if it's so, now let me continue here at the side. That means when I say y is equals to 80 degrees minus 30 degrees, the reason here will be what? Will be an exterior angle of a what? Of a cyclic quad. Okay, So we know that y is equals to 50 degrees. So that's how we do those problems, okay? Now, those are 3 theorems under a cyclic quad. I hope you are following, guys, okay? Now, let's go to the last group. The last group, it's now on what? It's on the tangents. Tangents. This is the first theorem. Theorem number 1 under tangent, which is initially theorem number 7. Theorem number 7 says tangent is perpendicular to the radius drawn at the point of contact. So since the tangent is perpendicular, this is one, tangent is perpendicular to the radius. Perpendicular means that here there is 90 degrees. Okay, and the reason is very simple. Radius perpendicular to the tangent. Okay, let me repeat again. This is a radius and this is a tangent. OP is a radius, AB is a tangent. So they are perpendicular, hence they form 90 degrees in their circumference. Okay, then that's the first one. Then we have another theorem here, theorem number 2. Theorem number 2, which is initially theorem number 8. Okay, this one says what? This one, the statement is very important because it's very examinable. The angle between the tangent to a circle and the chord drawn from the point of contact is equals to the angle in the alternate segment. What does that mean? It means that this angle here is equals to this angle in the alternate segment. This is the chord and this is a tangent. An angle between a chord and a tangent is equals to the angle in the alternate segment. That is very important. Every time when you see this one, you check your chord, you check your tangent. The angle between your tangent and the chord is equals to the angle in the alternate segment in the circumference. Okay, now they did say here PAB, which is PAB is equals to angle C. The reason here it is tan chord theorem. That is how we do that one. This is the second theorem under a tangent. Okay, now let's continue. The third theorem, this is another theorem number 3, which is initial theorem number 9. It says two tangents drawn to a circle from the same point outside the circle are equal in length. That means that this length and this length are equal. So now hence the conclusion will say AP is equals to PB. Why? These are tangent from the same point. They are both drawn from P to touch the circle. This one touches at A, this one touches at B. Hence, these are two tangents from the same point or drawn from the common point. Okay, so these are the 3 theorems under what? Under a tangent. Okay, now let's continue and close with these 2. Okay, these are not basically theorems, but we call them theorems because they have been proven to be true. So hence we continue with them. We say this again, it's another theorem. A theorem, okay? This theorem, I don't want to give them numbers. They speak about equal chords. Equal chords, equal chords. So once there are equal chords, that means the equal chords subtend equal angles. These angles, this is A and this is B, are equal. Why are they equal? Because these chords are equal. These chords are equal, hence this angle and this angle are equal. Same thing goes here. This is equals to that one. Why? Because this chord and this chord are equal. Okay, so they said here equal equal what? Equal circles, equal chords to equal angles. Okay, so the only thing between these two is that they have two different what? Two different circles. Since they have two different circles which are equal, therefore it means what? It means that the angles are equal. How do I know that these two triangles are equal? Look at their radius. This radius and that radius. You can see now that these two are what? Are equal. So these are the theorem. Equal chords subtend equal angles. That's the reason. Equal chords. Chords subtend equal angles. Equal chords subtend equal angles. That is very important for us. Equal chords subtend equal angles. Okay, so that is how we conclude on these theorems, and then we can look at these few problems on tangents. Then we will meet when we do the other problems with combined now theorems. Okay, now let's check. We'll take these three first, then we close this one. We'll continue on another video. So here I have this this is a tangent and this is a chord. Hence this angle is equals to that angle. So I have written that y is equals to 60 degrees. Why is y 60 degrees? This is the tan chord theorem. Tan chord theorem. Okay, and again we can find this is a radius, hence this will be 90 degrees. So x is equals to 90 degrees minus 60 degrees. Why? This is a tan perpendicular to the radius, or vice versa, rad perpendicular to the tangent. Okay, hence x here will be equals to 30 degrees. So I'm done with that one. Okay, now let's check the second one. On the second one, we are looking for this one. This is a what? A tangent, and this is a chord. Hence this one is equals to that one. So I can say angle B is equals to 38 degrees. Why? It's because of tan chord theorem. Okay, hence this, since this is a chord going to that circumference, I can also go to that circumference. So I know that C is equals to 38 degrees. Also tan chord theorem. Okay, but now I have what? I have a diameter here. That means this is 90 degrees. Hence it's 90 degrees. That means A is equals to 90 degrees minus 38. Why do I say so? Now this is a diameter perpendicular to the tangent. So it's a diameter perpendicular to the tangent. Remember we had radius perpendicular to the tangent, right? So when you also say diameter perpendicular to the tangent, you mean the same thing. Hence, A is equals to 58 degrees. So guys, let's close it here. This is how we do our problems in the introduction of Euclidean geometry. Thank you, guys.